Okay, here we go. Hello.
Are we on?
Yes, we're on.
Okay, so I wanted to show you, I want to show the Math 100 people, I wanted you guys to have an example on film of me adding these vectors, because it's a little complicated. I thought it'd be helpful for you to have a film to refer to. So, just like the one we did in class, I've just changed the numbers. Fred the Wanderer stops and ties his shoe. He then walks 600 meters due east. He then walks 700 meters due north. Fred sneezes and then proceeds to walk 1,400 meters at an angle of 40 degrees south of due west. I asked three things. First one, draw a sketch. The second thing, how far is he from where he tied his shoes to when he sneezes? And the last thing is find the magnitude and direction of Fred's total displacement. Okay, so let's, so we'll look at this solution. Lights are on. Okay, so you come get a better angle of this. So here's the picture. Here's where he starts here. Starts. So this shows the 600 meters to the east. So we use kind of this standard coordinate system where the positive x direction is to the east. The positive y direction is north. To help me remember this one, I always draw my bad picture of the United States of America. And then I remember it. Right? Canada's up, Mexico's down, that's south. New York is over there, that's east. California is over here, that's west. Okay, so we're going to use that coordinate system. So here's the first guy, 600 meters due east. Then we got the 700 meters due north. And then we got the 1,400 meters at an angle of 40 degrees south of due west. That's this guy. Okay, so we're going to add up the orange one, the green one, and the red one to get the total.
The blue one.
The blue one is the total. Very good. I was careful when I drew these. I drew them all to scale. So I made 600 meters equal to 30 centimeters. I made 700 meters equal to 35. Basically, I divided by 2. And so this is drawn to scale. I even measured the angle. So it should be our picture should correspond nicely to what happened. Okay, part B is kind of the simple question. How far has he gone? What's the distance? I'll read B real quick. How far is Fred from where he tied his shoes? So when he starts is when he ties his shoes. And sneezes is right there. So that's question B. Question B is just how far is it from tying shoes to sneezes? Well, that's just made by this triangle right here. I don't want to draw in here because I don't want to get this drawing too busy. But the distance is just 600 meters to the right, 700 meters up. So it's just, if I were to draw in a hypotenuse right there, it's just the length of that hypotenuse, which is 600 meters squared plus 700 meters squared. And you take the square root of that. And so I'll do that real quick on my calculator. Okay, and I'll do it twice just so I trust myself. Isn't this exciting TV watching me on my calculator?
Mm-hmm.
922. So the distance from tying a shoe to sneezing is 922 meters. Okay. Now we're going to get to the interesting part. The interesting part is finding this total. Finding the total, finding the blue vector. Okay, so the work that gets done adding vectors, most of it, almost all of it, is done in this little table where you're breaking everything up into the components. Because in order to add vectors, you got to break them up into their x and y components. Here, the x corresponds to east, and the y corresponds to north. So that'll get factored in. So of these three guys that we're adding together, I gave you two of them that are easy. The orange guy, which we'll do first, because he comes up first, he's easy. Why is this guy easy? Because he's all horizontal. He's in the eastern direction. Okay, the eastern direction is the positive x direction. So this guy is 106 meters in the x and nothing in the y. All right, because there's no north-south in this guy. There's no up-down in the board. Similarly, the 700-meter guy is also pretty easy because he's all up-down. He's all north. So since he's all north, he's going to have no horizontal component, and his y component is going to be in the positive direction, positive 700 meters. Okay, the red guy, the 1400-meter guy, he's going to be the painful one. So we have to do a little work for him. I'll redraw his triangle, scale down a little bit, so it looks something like that. It's 14. I'm going to draw it. It's this angle that we know. This angle is 40 degrees because we tell you it's 40 degrees south of due west. So since it's that angle that we know, I want to draw this triangle. And so this is the 1400 meters. Okay. And so we got to break these guys up into their components. One of the components is going to be the cosine, the other one's going to be like the sine. This guy, the x guy on the top, is going to be 1400 meters. He's the cosine because he's touching, he's adjacent. So it's 1400 meters times the cosine of 40 degrees. This guy's the opposite, so he's 1400 meters times the sine. Let me redraw that. 1400 meters times the sine of 40 degrees. Okay, so let me calculate those out. So for this guy, I get 899. I get 900 exactly. 900 meters. For this guy, cosine. This guy, I get 1073. Okay. And so we're breaking this triangle up into its horizontal and vertical components. This guy's adjacent, so he's the cosine. Now what we got to do is we got to put this on the chart up here. So this guy, the x component, is this 1073. But the important thing to remember is that's to the left, which is west here. That has a negative sign in it. All right, because anything to the left is the negative x direction. This 900 meters is also going to be, since it's down, i.e. south, it's minus 900 meters. Looks like that. I'm so surprised to see this exactly 900. I'm going to calculate it again. 40 sine 1400 times. Yep, 900. Isn't that funny? Okay, so now that we've broken them up into the components, now we can add. So we got a positive 700 and a negative 900. That's negative 200. We got a positive 600, a negative 1073. That's minus 473 meters. Right. And so now, if I kind of look at these values, so it's minus in the x total, so it's to the left, and it's minus in the y, so it's to the left and down. And if I look here at my picture, I can believe that it's minus 473. I say to the left, but here the left means west. And 200 down, I can believe that. Just looking at my total here. In fact, I could probably even kind of measure it. If this guy should be like 20 centimeters. Yeah, almost exactly, right? 20 because it's, no, like more than 20. This guy should be like 10. Yeah, it looks pretty good. Remember, I divided by 2 to get the centimeters? So it looks pretty good. I believe it. Now we want to take this and we want to write it as a magnitude and a direction. So I'll redraw it as 473 to the left or west and 200 down. Okay, and so we want to write that as a magnitude and a direction. So first we get the magnitude. You get the magnitude just from Pythagorean theorem, 473 meters quantity squared plus 200 meters quantity squared. A quick calculator. Excuse me. So I get 514 meters. And now we got to get the direction. So the kind of the natural angle to get is this guy right here, which I'm calling theta. So you can remember that from the TOA, the tangent of theta is the opposite over the adjacent. So that's 200 meters over 473 meters. So theta is equal to the inverse tangent of that. Get on my calculator, and we get 200 tangent, where's that at? There it is. I get 22.9 degrees. So now we can write our answer. So the magnitude of his total displacement is 514 meters, and it's at an angle of 22.9 degrees. So how do we say that? If you see it, it's below left. But below left is south of west. So it's 22.9 degrees south of due west. There we go. So that's how you add vectors. All of the work gets done right here. Okay, in this table. All right, thank you very much. I hope that's helpful. Have a pleasant day. Cut.